have analysis for all types of projects. So whether they're mainframe projects, like we've seen before when I showed you the definition, or also on the open side, with Java, C#, and SAP ABAP or NetWeaver. And because we analyze both sides, we can detect things like interactions between two applications, even if one is Java and one is a mainframe. So this is what I've done here. I have the top part is a Java application, and this Java application writes into queues, which are managed by MQ, and those same queues are read by a COBOL application. Okay, and these are the interactions. So there are 3 queues that were found. I also have it in the graph inventory on the left side, so I can just see which queues are there and just go directly. Okay, so if we take one of the queues, basically there is a Java method that handles the queue or puts information into the queue. And here I can go to the source code and I'll see it here. So this is an access queue. And on the other hand, we have this COBOL program. Let's go to the analysis source code, and you can see it does MQ close and MQ put. There are other things here in this program. So, and by this we understand that there is a relationship, and you can just see end-to-end impact. So you can see the Java classes, the methods call, then the COBOL programs, they're using files, they're using screens, they call other programs, even some tier 1 programs. So this is an example of a cross-platform analysis. This graph that you see here is the what we call a mainframe landscape. The agents, apart from bringing source code information, they can also bring what we call CMDB type information, like CPU, sysplex, LPARS, devices, information about the software installed, like DB2, MQ. So there's a lot of information. If we look at DB2, for example, and I go to the repository and I use the agents to bring DB2 information, I would get a list of all tables, all namespace, all fields, all indexes, or if I query kicks, I will see all programs defined there, all transactions, the mapping between transaction to programs, and so on. So this is the product of the CMDB information that I use the agent to get. And if we look at the application analysis, I'm going to go top down. So I'm going to start with a graph that shows how applications share information on the mainframe side. So here, for example, I have 3 applications that share data sets. One of them, which is investment banking application in COBOL, changes and reads and modifies customer information, and then I have another application, which is the reporting application in tier 1 that uses this data. So this basically shows me how data is being shared between my applications, whether it's IDMS records or DB2 tables, or here is KICS files and MQ queue. And the direction of the line also shows me how the data flows. So manufacturing writes into this queue and procurement reads from the queue. And if we look at this bunch of files and I want to understand which files are these, I can just expand and I'll see exactly which files are being shared and whether a given file is just read by one application or also modified. So this is the direction of the line. Next, I can drill down into an application. So let's say I need to do a change to manufacturing. The first view when I drill down is what we call the cluster view, and it shows me basically the architecture, or it tries to show the architecture of the application, so the different areas. And the way that we do this is we take all of the relationships between the components, like the programs and screens and files and tables, and we try to group them according to the components which interact the most. These are these clusters. So each cluster here hides a group of nodes, right, which I can unfold, and you will just see all of those interactions. And there were put in a single cluster because they had a lot of interactions. And I can just unfold everything, and still you would see those areas. And of course, we'll see all of the relationships. So there's a lot of relationships here that we have, and all of these lines, for example, a line that goes between a program and a file is a read next. And I can go to the source code and see this. And we have lines going between programs, lines going to a screen, and so on. So this gives me, let's say if I would need to maybe try to partition this application, maybe I'm trying to go to services or do something, this can give me a hint of areas which may be related from the logic point of view. Now, if I want to understand other things like, let's say, the control flow, usually it's very hard to understand because there's a lot of relationships here. So what we allow you to do through the graphical interface is do some kind of filtering, right? So first, for a control flow, I will change to a tree view instead of a circular layout. Then I would filter out, let's say, files and screens, and now I'm left only with programs and transactions. Okay, so this is just we'd say the call tree. Now, if we look at one example here where a program invokes a transaction, so it does return trans ID. Basically, it invokes this transaction, and there's another one here. So I can, for example, ask myself, is there another way in the control flow of my application where I can get from this program, let's say, to this transaction, but not directly like I see here? So what this also allows me to do is to find the path in the graph, right? So I would say this program, 3190, and can you reach this transaction? And the graph filters, and what I see is that, yes, I can get from the program to this transaction in other ways. And I can then, if I need to change this program, I can go and ask to see how the program looks like from the inside, right? So let's say I wrote this program 1 year ago, or maybe I wasn't the guy writing it, and now I need to go and understand it quickly. And the graphical interface allows me to quickly understand how the control flow works here, right? So these are in this case it's COBOL, so these are fall through, these are go to, there are no perform statement, these are external entities like files, called programs, and again I can filter things out here. So if I ask myself, how can I get to, I don't know, a place where I modify, let's say, or I send information into the screen, I can right-click and say, okay, let's filter, and I will get a smaller view of the program with less components. You can also see this as a tree. Right? So comparing to what I've started with, it's going to filter out and just show me the specific flow which I'm interested in. And I can further drill down to see a flow chart of the program. So this would be the if statement, move statement, go to statements. Again, you can go from here to the source code, and like all of the graphs, you can export them. So if you want to, let's say, include something as part of documentation, you can export into PDF or EMF, which can go then to Visio. And there are other graphs. There are scheduling graphs. There are job-related graphs here. And apart from the graphs, there's also where-used information in the tabs. Okay, so we've seen the project tab, which helps me allows me to create the project. We also have a tab for each type of data source. For example, for DB2 or for IDMS or Datacom or IMSDB or IDOBUS. And the way that this works is that it shows me everything basically I need in order to understand, in this case, how DB2 is being used. And it's built on these trees with different levels. Okay, so the first level in my tree are the tables. So this would immediately show me which tables are being used in my application. So this is not to say all tables in DB2. There are probably many more tables in DB2, but this is actual these tables that actually are being used in the code. We do get information. So if we want to see definition information from DB2 and we used the mainframe agent, we can get SIEMDB information about the table as well. So for example, the database name, the user who created it, when it was created, when was the last time the table was modified. In some cases, if something goes wrong and you don't know, you can just say, okay, open it up and someone just changed the table, or I don't know, this can give you some hints when you do a issue resolution. Now, if you look at who's using a given table, so I have two applications using that table. Which programs in investment banking, two programs. One program is just doing select. I can go to the code, and another program doing delete, insert, select, update. So probably this program in investment banking is responsible for customer information. This is just reading it for other needs. And one tier 1 application. Okay, so basically the order of the tab now answers the question, given a table, which applications and programs are using it. But I can also ask the other way around. So let's say ACCT3, it's not doing customer information. So I'm wondering if I can get the usage by seeing which other tables it uses. So what I'll do is I'll just change the order of the levels, and I'll put the programs on top of the tables, and I'll reload. And first I see that only two applications use DB2 in my landscape. And this program, which I was wondering about, which I know uses customer information, but I know it's not the main program for customer information, I see that it's doing a lot with account information. So this is probably what it's doing. Now I can ask another question. Within my tables, which tables I'm deleting information from within my application. So again, I would change the order of the tab. I would put the call type first, and then the table type. And I'll see the statement type, and I'll expand delete. And here are the tables which I'm deleting from, or inserting into. And who is inserting? This application. Okay, or deleting, right? And this is available also in the other tabs. There's also a lot of batch information, which usually is very useful. So if I have, these are all of the data sets which are used within my jobs that I've analyzed. Given a specific data set, I can see which jobs are using it or creating or deleting it. In this case, two applications are using the data set, wealth management through these jobs. And which programs are using the data set, I can just choose. And we look at the bottom part, it will take us from the physical name to the usage of the logical name in the program. So this goes from left to right. So there is a job, it invokes a proc. There is a step, this is the DD card that maps to the physical file. There is a symbol resolution. Okay, here it's not fully resolved. The job actually puts the symbols. And then there is a PGM here. It's a load model. Inside, we found 6 programs that map to the logical name, which is tape.ia, which is the name basically that is mapped here in the proc. So this is physical to logical. We also have the other way around. If you go to Files tab and you choose I don't know, some file here, and this is tape.ia, and it's being read in this program. But now, how do I know which data sets I can read here? I just go here and I expand, and it turns out that there are 5 different data sets that can be read in this statement. So this is logical to physical.